Hey everyone, Double Aaron here with Big Mikey doing the Briggs-Rauscher oscillating chemical reaction. So what is an oscillating reaction? An oscillating chemical reaction is any reaction that alternates between two compounds or products. And today we're doing the Briggs-Rauscher reaction, and we use 4 experiments to help us understand how it works. This is one of the very few oscillating reactions that we know of. This reaction goes from colorless to amber, blue, black, and then back to colorless over and over again. So here are all the materials we used. For chemicals, we used 3% hydrogen peroxide, sodium iodate, starch solution, malonic acid, manganese sulfate, sulfamic acid, and sodium thiosulfate. And we also used 3 cups, beaker, pipette, stir sticks, small teaspoon, scoops, and a rack. So for our first experiment, we labeled 1 cup A and another cup B. Then we used a beaker and poured 10 milliliters of water into cup A. Now we added half a scoop of sodium iodate and 1 level scoop of sulfamic acid and stir it until it's dissolved. Then we put 10 milliliters of hydrogen peroxide into cup B. And 1 full scoop of malonic acid. And a small amount of manganese sulfate into cup B. Then we shake the starch solution and mix 3 to 4 drops into cup B. And then we keep mixing until the solution turns brown.
Bruh.
So yeah, the experiment didn't work, and now we're doing 5 times the recipe. So here we have 2.5 scoops of sodium iodate and 5 scoops of sulfamic acid. So once we had solution B, we combined them to get this amazing looking reaction. So we poured out half the original reaction to do more experiments with, and this is what the remaining looked like after 30 minutes.
This is the moment in time when I just want to rip your experiment out of your hands and do it myself. So that's okay. Go ahead.
So for our second experiment, we're going to remove the color from the first experiment. We did this by adding sodium thiosulfate crystals until it became colorless. So here we have the leftover reaction from the first experiment, and now we're slowly dropping in sodium thiosulfate crystals. After a while, we added enough crystals that the color started disappearing, and it has this cool effect when we stir it. So by now the reaction looks complete, but there's still active chemicals in the solution. When we decolorized the mixture in experiment 2, the blue color came back eventually, which is basis for a clock reaction. An iodine clock usually contains hydrogen peroxide, thiosulfate, iodine, and acid. And these are the components that are left. But we don't know how much exactly, so we'll experiment. So first we take the leftover solution from experiment 1 or 2, and then we made a sodium thiosulfate solution from 2 scoops of sodium thiosulfate, or more if you're scaling it up like us. And then we use a dropper to add the solution, drop by drop, to the dark mixture until the color just disappears. And then the blue color will suddenly reappear. We continue doing this until one of the components is used up. So now we're making the solution to drop into the reaction. After we dissolved it, we started dropping it into the solution. By this point, being the good chemists we are, we gave up and dumped the rest of them. So for our 4th experiment, we're going to gather some clues and hopefully understand how the oscillating reaction works. And we're going to start by finding what sulfamic acid does to the reaction. So first we set 2 cups of hydrogen peroxide and half a scoop of sodium iodate in each cup. And then we added 1 scoop of sulfamic acid into one of the cups. And of course we did 5 times the amount. So here on the left we have 50 mils of hydrogen peroxide with 2.5 scoops of sodium iodate. And on the right we have the same thing, but we added 5 scoops of sulfamic acid. After the sulfamic acid fully dissolved into the solution, we see it turn the solution into a bright amber color and there's bubbles forming. So from this, we see ambered colored bubbles forming in the cup with the sulfamic acid, and nothing's happening into the other cup. This tells us that the whole reaction from the experiment 1 must be acidic to react. Now we add a small scoop of sulfamic acid to the control for the next part. So we took that cup and added a drop of starch to it to test for iodine. And since we did put iodine in it, it turned a bluish purple. and the amber color we saw when mixes from the iodine forming iodate. We see as we're adding the drops, little parts of it are turning blue and purple before spreading out to the rest of the solution. We should have added more starch solution to make the whole thing turn purple. So for the last part of experiment 4, we took the other cup that had sulfamic acid and added some scoops of malonic acid, which will make the solution colorless. This tells us that the malonic acid is involved with the reverse formation of iodine. Now we add a grain of manganese sulfate to the solution, which will cause the color to return back to amber, and this appears to reverse the solution to how it was. And these are all the clues that can help us understand how the reactions work. So here's the other beaker that had the sulfamic acid, and now we're going to drop in the malonic acid. So we see the malonic acid is dissolving in the solution and is taking away the color. This is because it's reversing the formation of iodide back into iodine. So now we're adding a little bit of manganese sulfate, and it should give us that same amber color that we had before. And finally, here's the complete reaction equation. And we got our source from Amazon called Fascinating Oscillating Reaction Kit, and it had all the ingredients and preparation and instructions that we needed. I hope you enjoyed our video, and thanks for watching.